All right, let's read the problem. Two forces with magnitudes of 100 newtons and 500 newtons act on an object. The angle between the two forces is 30 degrees, with the 100 force being pulled along the positive x-axis. Find the direction and the magnitude of the resultant of these forces. All right, so I'm going to draw a diagram. We're going to say this is the object. And two forces are tugging on it or pushing on it. I don't know. But here's what I do know. The force that has a 100 Newton is being pulled along the x-axis right here, which means its direction is 0 degrees. It's not going up, not going down. It's going horizontal. That's 0 degrees. Then we have another vector or another force, but this force is going at a diagonal and it's creating a 30-degree angle. So, for the sake of us all having consistent notes, this vector down here that's stuck on the x-axis, let's call that vector C. And remember, vector C has a force of 100 newtons. The vector that's creating the 30 degrees, let's call that vector D. And remember, its magnitude is a lot greater, it's 500. And the instructions are telling us to find the direction and the magnitude of the result of both of these pulled together. Add means pull together. So for vector C, we're going to take that 100 and we're going to multiply it by the cosine value of 0 degrees. And then we're also going to do 100 times the sine value of 0 degrees. And we're going to convert it into component form because I can't do anything unless it's in component form. So that's our goal in this column right here. Over here, I'll start my other work. All right. Vector D is going to be 500 times cosine 30, 500 sine 30. Now remember, cosine 0, y'all, that's the beginning of the unit circle. Right here. Remember the beginning of the unit circle, cosine has a value of 1. Y'all, I'm just going to put it up here. Cosine at 0 is 1. Sine at 0 is 0. So 100 times 1 is the first component for vector C. 100 times 0 is the second component for vector C. Now remember, vector D is at 30 degrees, and that is going to be root 3 over 2 and 1/2. So we're going to do, y'all are going to need to do your calculator. Make sure you get these numbers right on the calculator. 500 times root 3 over 2, we're rounding to the nearest tenth, and then 500 times 1/2. Go ahead and practice that on the calculator because you know I can't help tomorrow. Okay, it helps if you turn it on. 500 times root 3. So we have an 866 number. Don't forget it's divided by 2, so hit divide by 2. All right, we're going to round to the nearest tenth, and that just makes that a whole number of 433. The next component is going to be 500 times 1/2, so that's just 250. All right, finally is how we're going to start getting the numbers we need. We need numbers all about the resultant. So the resultant force is always denoted with the letter R. So we're going to make a brand new vector called vector R, and we're going to add straight down. So the first component for vector R is 533 degrees. The next component is 250. Now it's just stuff from Tuesday. So we need to find the direction. So easy. Hit second tangent and do 250 divided by 533. Second tangent. And don't forget we are rounding to the nearest tenth. So 25.1 degrees. And then we're going to find the force, the magnitude. So here's where you need to make sure you're good on the calculator. Remember, it's 533 squared. I'm not trying to put that all under 1 square root, guys. So I'm just writing 533 squared using that little 2 plus 250 squared. Then I'm going to hit enter. Then I'm going to hit second square root, second answer. Second square root, second answer. You should have got 588.7. And y'all, it's a word problem, so let's write Newton. It's over here. All right, let's do it one more time, and then we'll talk about questions. That's the answer. Found it. Moving on. All right, number 8. Number 8 has 3 forces. Okay. 3 forces with magnitudes of 75 pounds, 100 pounds, and 120 pounds act on an object at angles of 30 degrees, 45 degrees, and 120 degrees respectively with the x-axis. But y'all, it doesn't say it's being pulled along the x-axis. It's just stating it's starting in standard position. So again, if you do not see those words, then it's not going to be 0 degrees. Let me draw a diagram for this. We do have 120 degrees, so I'm going to make sure that I save room for quadrant 2. All right, here's my object right there, the origin. 75 pounds. We're going to call this one vector C. And that's at 30 degrees. The next one will be vector D. And that one has 100 pounds. And that's 45 degrees. And then our last vector is going to be vector E. It's over there in quadrant 2. And it has a force of 125. And remember, it's at 120. I'm going to start consolidating my steps a little bit. Here's what I'm going to do. I'm going to write vector C right here. And the ordered pair, remember, for 30 degrees is going to be root 3 over 2 and a 1/2. So I'm just going to go ahead and write the ordered pairs there and remind myself that I am distributing a 75. For vector D, it's going to be 100 times root 2 over 2 for both the x and y coordinates. And vector E, y'all don't forget for vector E, your x coordinate's negative. So it's going to be 125. We're at 120 degrees. Remember, that's 2 pi over 3. So negative 1/2 is the first coordinate. The next coordinate is root 3 over 2. Moving on, we're just going to distribute. Again, I'm going to have to turn on that calculator because root 3 is not a perfect square. So 75 times root 3. And then don't forget we're dividing by 2. So the first component for vector C is going to turn into a whole number again, 65. All right, 75 times 1/2, that's 37.5. Guys, make sure you do the work on the calculator. This is my 4th time doing it, so I have these numbers memorized. Make sure you get this. Do that now, 70.7. Make sure you're set on that calculator. All right, my last component, 108.3. Same process, y'all. Add them up, and then we're going to start finding the answers. After you add it, remember to label it vector R. Y'all go ahead and find the direction, angle, and the magnitude. So, kind of shifting gears a little bit. A ball is hit with an initial velocity of 130 feet per second at an angle of 49 degrees with the horizontal. That just means along an x-axis. It does not say pulled along the x-axis. Sketch a picture and find the vertical and horizontal components of the velocity. Y'all, velocity is magnitude. So here's an x and y grid. Here's where someone hit a ball. The magnitude is 130 feet per second, and the angle is 49 degrees. Is 49 degrees on the unit circle? It's not, y'all. This is how easy this is. Draw a blank for your horizontal component and draw a blank for your vertical component. On the calculator, literally, you are going to take the magnitude and type cosine 49 degrees, and then you're going to round to the nearest tenth, and that's going to be the answer. That's all we have to do. So 130 cosine 49, enter. Just round that. Make sure you get 85.3. And it's a word problem, so we have to write feet per second. And then, I'm so lazy, I'm just going to arrow up and just type over cosine, just hit sine, and then hit enter, and then 98.1. So the other one is 130 sine 49 degrees, and that's 98.1 feet per second. That's how you do those. So anytime it's just like one scenario without multiple forces, if you don't see the word resultant, if you see vertical and horizontal components, don't overcomplicate it. Let's look at this one. A bullet is shot from a gun with a velocity at 1800. Okay. It's fired at an angle of elevation of 22 degrees. There's my picture. Oh, well, I'm listing vertical first because I wrote in pen, and I'm not going to scratch it out. Then I'm going to list my horizontal. All right, vertical is going to be 1800 sine 22. Horizontal is 1800 cosine 22. Just make sure you round to the correct tenths place. 1800 sine 22. So my vertical, which I'm listing first this time, is 674.3 feet per second. I'm going to be lazy and just arrow up, hit cosine. And then your horizontal is 1668.9 feet per second.